So 3i Atlas is the third interstellar object. So that's why you have 3i. Atlas is the name of the telescope in Chile that discovered it, only half a meter in size.
For years, astronomers were confident they understood how rogue objects drifted into our solar system. Comets, they said, follow predictable shapes, predictable tails, predictable chemistry, cosmic snowballs knocked loose from distant reservoirs. But then 3i Atlas arrived, and every rule broke at once. First came the new paper, quietly uploaded, peer-reviewed, and now spreading like wildfire, that claims the comet theory is no longer enough. According to the authors, 3i Atlas is not a comet. It never behaved like one, and now they say they finally have proof. The story begins with something the public never noticed.
Okay, so an astrophotographer named Ray just spent weeks imaging something that's currently leaving our solar system, and what he found is making absolutely zero sense.
3i Atlas refused to shed mass like a normal comet. When a comet approaches the sun, its fragile ices vaporize, releasing dust and gas that create the glowing coma and the long, elegant tail. But measurements from multiple observatories showed almost no outgassing at all. It glowed, yes, but the glow was wrong. Too stable, too uniform, no volatility spikes, no chemical fingerprints that matched standard comet compositions.
I was taking a look at the recent Hubble pictures. They were released like a couple of days ago. I was looking at close-up of Hubble. I noticed two things. Like, one is the Comet 3 Atlas looks like a dot.
Researchers tried to explain it away. Maybe it was coated in an unusually thick crust. Maybe it was a spent comet nucleus, one that had burned off its ices long ago. But then the brightness of 3i Atlas began to increase as it left the sun behind, moving farther into the cold. That is the opposite of what comets do. Comets dim as they retreat. This object brightened. The paper calls this non-thermodynamic luminosity drift.
NASA has confirmed that interstellar object 3i Atlas is not natural at all, but made of industrial material. Now scientists are scrambling for answers.
Which is a polite scientific way of saying nobody has any idea what is going on. But the real blow to the comet theory came from spectroscopy. Using ultra-sensitive infrared instruments, teams attempted to identify the object's surface chemistry. Standard comets contain water ice, carbon monoxide, carbon dioxide, methanol, ammonia, volatile compounds that evaporate easily. But 3i Atlas returned almost no such signals. Instead, the spectral lines hinted at something much tougher: refractory minerals that usually survive only in the inner regions of solar systems, near young stars. In other words, this object may have formed in a place far hotter and more violent than any comet nursery. The paper's authors describe it bluntly. 3i Atlas displays an unexpected predominance of high-temperature silicates incompatible with classical cometary models. That single sentence detonated years of assumptions. If the object contains minerals forged in blistering heat, it cannot be a simple comet kicked out of a distant, icy cloud.
Okay, so 2 months ago, scientists detected something strange entering our solar system.
It must come from a different kind of environment altogether. Then came the spin rate anomaly. When astronomers tracked the object's rotation, they found that it spun faster than a normal comet nucleus should be able to withstand. Cometary bodies are loosely bound rubble piles. Spin them too fast and they fly apart. But 3i Atlas held together, shrugging off forces that should have ripped it in half. Something about its internal structure is stronger, denser, more cohesive than anything we've seen from an interstellar visitor. So what is it? That question hung in the air for months until a new set of radio observations revealed the strangest clue of all. As 3i Atlas passed through the inner solar system, it emitted faint, repetitive modulations in reflected radio waves. tiny shifts that appeared too ordered to be noise. Not a signal, not communication, but patterns consistent with a surface that is unnaturally smooth on some angles and jagged on others, almost like a manufactured material, with uniform ridges or facets. The authors do not claim artificiality, but they do note that the geometric regularity of reflection may imply non-stochastic origin. In simpler terms, the surface patterns don't look random. This is where the paper takes a turn. It argues that we should compare 3I Atlas not to comets, but to objects called refractory planetesimals, rocky fragments left over from the early days of planetary formation. These bodies are made of tough minerals, dense metal silicates, and can survive extreme temperatures. If such a fragment were ejected from a collapsing system, accelerated by gravitational slingshots, and thrown into interstellar space, it might look exactly like 3I Atlas today. But even that doesn't explain the strange brightening, the stability, or the anomalous reflections. So the authors propose something bolder. They argue that 3I Atlas may be a fragment of a shattered exoplanet, not a planet like Earth, but a young world torn apart by tidal forces near a massive star. Its crust vaporized, its mantle cracked, and its molten interior launched outward as superheated debris. Over millions of years, that debris cooled, hardened, and began drifting through interstellar space until it wandered into our solar system. This would explain the high-temperature minerals, the dense structure, the spin resilience, and possibly even the smooth ridges left behind by rapid cooling. But even that theory, they admit, has gaps. Something about 3I Atlas continues to defy expectations. Most planetary fragments are irregular, chaotic, and scarred. But this object displays an almost aerodynamic elongation, similar to, but not identical to, Oumuamua. Both objects came from different regions of the galaxy, yet both share an inexplicable cigar-like shape. Meteoric erosion does not normally produce such uniformity. Catastrophic explosions do not either. So the community is left wondering whether there is a class of interstellar objects we have never recognized before. One line in the paper summarizes the growing unease. 3I Atlas suggests the existence of large-scale interstellar populations composed of non-volatile, high-strength bodies with coherent morphology. In other words, there may be millions of these things out there, neither comets nor asteroids nor debris we understand. The next piece of proof comes from trajectory modeling. When 3I Atlas was first detected, astronomers calculated its inbound velocity and discovered that it was traveling too fast to be a relic from a nearby stellar system. Its origin seemed much farther away, possibly dozens of light years. As researchers traced its path backward, they found that it likely came from a star system that no longer exists in its original form. That system experienced a violent event, likely a supernova or a stellar collision, sometime in the last 100 million years. If 3I Atlas is a surviving shard from that destruction, it carries the chemical memory of a world that died long before humanity existed. But the most shocking part of the new paper lies near the end. After analyzing all available data, spectral, photometric, rotational, structural, the authors conclude that the comet theory fails completely. The object's behavior is inconsistent with thermal models, dust production models, mass loss models, and orbital evolution models typically used for comets. They write, 3I Atlas cannot be reasonably categorized within the classical comet taxonomy. Its physical parameters contradict every defining property of cometary bodies. Instead of a dying, icy wanderer, it may be a survivor of cosmic violence, a relic forged in stellar fire and hurled across the galaxy. And then, the final piece of proof arrives: polarization measurements. When light reflects off a surface, it becomes polarized in specific ways, depending on what it hits. Ice polarizes light differently than dust, which polarizes differently than rock or metal. The polarimetric signature of 3I Atlas matched none of the comet types on record. Instead, it resembled the signature of dense silicate materials compacted under extreme pressure, materials that form inside planetary mantles, not crust, not ice, mantle. This is the strongest evidence yet that 3I Atlas may be a chunk of a destroyed planet. But there is one more twist. The paper's authors noticed that the object's polarization curve aligns closely with materials forged during high-energy tidal disruption events, rare astrophysical catastrophes in which stars tear planets apart, atom by atom. Only a handful of such events have ever been observed. If 3I Atlas truly carries that signature, then humanity has just encountered a piece of a world that was shredded by its own sun. Imagine that, a cosmic tombstone drifting silently into our backyard. The object is already past us, fading into the void. We will likely never see it again. But the data it left behind forces a reckoning. The old model, icy comets from distant clouds, is too simple for the universe we live in. Interstellar space is not filled only with frozen wanderers. It is littered with fragments of broken worlds, each carrying secrets about how violently stars and planets can die. 3I Atlas is not a comet. It is a messenger from a catastrophe we never witnessed, proof that the galaxy is more chaotic, more destructive, and more extraordinary than we imagined. And if the paper is right, this will not be the last such visitor. More fragments are coming, more survivors of stellar disasters, more clues about the hidden violence shaping the Milky Way. The comet theory isn't just cracking, it's collapsing. And 3I Atlas just drove the final spike through it.